Hey everybody. In class today, I was asked to share the instructions and basically like how to do the solution composition assignment. So that's what I'm doing today. Let's go ahead and share the screen. And there it is. Share the sound and optimize for video clip. Just what the heck is that? Yeah, I'm sharing the correct screen. Okay, so working on the solution composition, we'll find that in the Unit 4 folder. Actually, you'll find the assignment itself right there, but I copied and pasted to the Unit 4 folder, so let's just go ahead and check that. Now, to zoom in, I'm gonna breeze past numbers 1 through 3 to focus in on the simulation section here. Okay, so the simulation section, what are we doing here? What we're working on is just just familiarizing yourself with how concentrations kind of work. So if we click on that, we'll get to this page right here. And so we went through the instructions. I'll do them again. Um, but just to read through them, what we want to do is we want to change the solute from solid to solution in the top right corner. So if we look in the top right, here's the solute. So we don't want solids, we want solutions, so we could measure it. We want to pick 3 solutions and then gather the following information. So we already did drink mix in class, we did copper sulfate in class, and it's up to you to pick your third solution. Scrolling back up, we want to use the purple gauge to measure concentration. So if we move the sensor down over here, we see the concentration starts off at 0, 0, which makes sense because we haven't added anything to it. It's just water. And we're going to add solute by pressing the red button. So let's get the information down. What do we have? We have drink mix. That's our solute name. Cool. Our initial solution amount, well, we've got half a liter, so 0.1, 0.1, 0.2, 0.3, 0.4, 0.5 liters. And so we start off with that, 0.5 and 0. What we're going to do is we're going to see what the molarity, see what the concentration is once we add enough solution to bring the volume up to 0.8. So we're going to press the button and bring it up to 0.8. So 0.6, 0.7, and 0.8. It doesn't matter if we go a little bit too close or a little bit short. We're just going to round. We're going to round that up to 2.1. The concentration at 2.1 or at 0.8 is 2.1. So what we have to do is just add drink mix solution until the volume reached 0.8 liters. Next up, what we're going to do is we're going to just see what happens once we evaporate it all the way down to 0.2. And so the instructions there are use the bottom evaporation slider to bring the volume down to 0.2. So here's the evaporation slider. We're going to bring it down. So 0.7, 0.6, 0.5, 0.4, 0.3, and there it is, 0.2. Again, more or less. So when we look at the concentration, again, we're just going to round it up. I'm going to round it up to 6.0, right? Because that's what we're looking for. We're looking for concentration here. So 6.0 molar, and it is saturated. Next up, we want to know the molarity after adding water to 0.5. So we're going to use the top faucet to add water until the volume reaches 0.5. So here it is, top faucet, 0.4, and 0.5, 3.3. Right, so 3.3. And then after draining the water to 0.2, we can just use the bottom faucet to drain it right back down to 0.2. Whoop, my bad. Did a little bit too much there. Okay, so if I didn't dilute it with the extra water, we would see that the concentration should be exactly the same. And so the point here is this. Evaporation removes specifically the water that is in that solution, diluting it. By just adding and removing water, or by just removing the water, like the entire part of the solution, the concentration doesn't change. We're just lowering the volume. Uh, by adding water, we do change the concentration because now all the solutes are being dissolved more and more. And so for number 8, we're getting into this math here. We just want to calculate the moles of our solution when it's at 0.8. So what we did because we are going to use our molarity equation. Moles over liters equals molarity. We want to figure out moles. And so at 0.8 liters, that's our volume, 0.8, we had 2.1 as our concentration, 2.1. And so we just, solve for x. 0.8 times 2.1, that's about 1.7. For number 9, we're looking at what happened to our solution concentration as we evaporated it. So we were at 2.1, and when we evaporated it down to 0.2, the concentration rised. It rose from 2.1 to 6.0. It did become saturated, and so what we saw was, let's see if I could do this proper. I know it saturates around 5. So once it's saturated, we see that all these crystals started growing, and it was kind of a lot. And so that's a sign of a super saturated solution where your crystals are starting to come out of solution. What happened to the molarity after you added water? Well, it diluted, right? And so ideally, I would have practiced with that equation, but the dilution equation, but we'll do that at a later point, possibly. So that is basically a rundown for what you're doing in these solutions. Uh, Slow it down, pause it, use whatever you need. But that is essentially going to be it for that assignment. You'll be doing that for your third solution, and you'll be doing kind of comparisons for the bottom half of the second. All right. So have a great rest of your day. Bye-bye.